Start recording. Hello, everyone, and welcome to Handmade Heroes, show where we code a complete game live on stream. We are actually back after a pretty long break. We were on our RSI leave for a little while, and then we did some streams that were not specifically coding on the game. We just did some chat streams so I could rest my hands, and then we also did one where we switched over to 4Coder, and that was precipitated by the fact that since I was on RSI break, I took that opportunity to switch over to a modal keyboard binding, which is still kind of in progress. Like, I only just did the basic work of switching to a modal key binding, which is sort of switching to a modal version of what I already was using for my Emacs key bindings, which is not really the best modal key binding, certainly, but it's what allows me to keep editing on a daily basis without losing too much speed. Over time, I would like to mutate the binding around a little bit, because now that it is modal, there's things I could do, like things from VI that are cool that I could borrow, like, you know, that are based on the modality that really maybe didn't make a lot of sense before because I didn't have a modal key binding. I can start using those, and I'm not using those yet. So anyway, I switched over to that, and trying to use modal key bindings in Emacs was a nightmare. There were so many problems with it. I did get it working, and I am using it at work right now. But I wanted to try switching over to 4Coder because Alan Webster, who's one of the people on the stream, Mr. Fourth Dimension, if you don't already know, made a pretty cool editor that he's been working on in his spare time. He's a student. But the editor's already better than Emacs in a lot of ways. And mostly the only thing, in fact, the only reason right now that I'm not using it even at work is just because there's like a few bugs or missing. There's like a few little tiny things that have made it so that I can't quite switch over there. But it's like shockingly good for how long it's been in development, and I'm really pretty excited about it. So we switched over to it here on Handmade Heroes. So for those of you who didn't follow those streams that were sort of not Handmade Hero streams, but just me like going over 4Coder and implementing some features like in the customization thing, that's what this sort of new editor situation is. And so I can sort of show it to you real quickly here. If we're in a Handmade Hero, right, this is the actual editor. And I made a batch file like we had the old Emacs one to load it. And essentially, like, it works, you know, it looks like a standard editor. There's nothing in particular that I think will be confusing to people on the stream. But in general, you know, it's very much does the same sorts of operations that I typically would have done on Emacs. And it also allows programmability in C, which I've sort of leaned on pretty heavily. So there's a 4Coder Casey file that I've made, which is basically like my C code that does all the things that I wanted it to do to basically copy what I do in Emacs. So yeah, this is basically just a long-winded way of saying that's what's going on differently here. And this is a program that you can also get yourself. So if you want to follow along with this instead of with Emacs, you can actually type in 4Coder to your search window. And there's a Patreon page for it here to support Alan's development on it, which would be awesome if you did. It's a great editor. I am really happy about its development. And so if you wanted to support it, that would be awesome. But if you support it, even I think at $1, you get access to it. And if you support it at $5, you get the whole programmability thing and all that stuff. There's even a $10 tier for people who are awesome. And I contributed my config to this. So if you want to be a supporter of 4Coder, you can also get my config included with that at the high tier. So please check that out. Like I said, I think it's a really awesome project, and it's been really helpful to me, and I'm really hoping that other people in the community take to it, so we can sort of have our own editor that is sort of nice for us to use and nice for the sorts of things that we do, as opposed to other things like Atom or whatever, which are clearly targeted at a very different way of working and a very different set of priorities. So that's really it for the changes. Other than that, nothing's different. We'll just go back to programming Handmade Hero exactly the way that we were. The only thing that I was going to point out is in 4Coder, I actually I probably should have done this in Emacs a long time ago. I didn't. I just never got around to it. But in 4Coder, since now I can program in C, it's really easy for me to add things. In Emacs, it was always very laborious for me to add things because I don't program Lisp natively, and I barely know my way around Lisp. So, if you look at what I did in my Emacs config file, it's this really kind of janky, like Casey tries to sort of make Lisp do things, but he doesn't really know how to program Lisp, so it's obviously stupid kind of stuff. But since I know how to program C, I can always hack something together in C. And yeah, maybe it's not going to be the greatest code in the world, but it's my editor. I know the boundaries of what I'm trying to do. I'm not trying to make some kind of robust code that I'm, shipping to people or doing whatever. And so when I can just open up a C file and edit my editor config in C, that's pretty great. So one thing I did really quickly is I just made this notion of a PRJ file, which is literally just a list of basically paths, so that I could make it so that it would automatically load a project for me, load all the files, so I don't have to keep loading the files. In Emacs, I never had the concept of a project. There's even stuff in Emacs, I think, to help with that, and I never did it. So one thing I wanted to do is just get that into Handmade Hero. So in Handmade code, I could just do handmade.prj as an actual thing. Of course, I always forget. I've never actually made a way to create new files for some reason in 4Coder. There is a command for it, and I never bound it to anything. Eventually, I will when I actually remember. But point being, I need something there to open. There we go. Okay. So let's see. Handmade.prj. So in this project file, all you have to do is list the directories you actually care about. Now, in Handmade Hero, we only have one thing we care about, which is this directory, right? So I can just say oh yeah, there's the Handmade code directory, and that's it. And then you can also do a thing where you can set the compilation directory. So the first line in the file I think I did is always the compilation directory, I want to say. And so basically this is where you want to run the build from, and this is then everything else after it was what directories to load. So it works as kind of nice because I have a couple of different directories where stuff is in, and I just list those directories and everything gets loaded, and it's kind of cool. So anyway, I did that for 4Coder, and it's just been kind of nice. So I wanted to do it for Handmade Hero, even though it's kind of not that necessary. It's not as necessary because there's not as much stuff. It's just kind of nice to have that. And then when you load a PRJ file, it automatically does that load for you, or at least in theory. That was how it was supposed to work. So I think, if I'm correct now, and I actually wrote the code properly, then whenever the next time you're in here and you run fored, you can kind of go in and say oh, okay, I'm going to load handmade.prj. And then if you look at your buffers, they're all pre-populated with all of the stuff. And it loads H's and CPPs. I probably should have made it load.bats as well. I didn't, but we could always add that at some point if we want to. So that's it. Everything else about it is the same. And a lot of it's I made pretty similar to Emacs. So like I said, everything should look pretty familiar when we're working. If I hit the build key, it builds on the other side, and it does exactly sort of what you would expect. So the difference, and this would have been a difference on Emacs as well, that will take perhaps a little bit of getting used to if you're trying to understand what I'm doing on the stream, is like I said, I switched my Emacs and then correspondingly 4Coder. I switched them to be modal. So what that means is that when I was in Emacs, you just type keys and the text would come out, and then you would hold down the control key or the alt key, and I would push something, and then that would that would actually do the special function. The idea behind a modal binding is to try to keep your hand not be doing so much with your hands. And so you don't want to have to ever hold modifiers if you don't have to. Caps lock, I have control bound to caps lock, so I don't know that control key was particularly bad for me, but alt is a real bad motion with your thumb kind of, I suspect. So I definitely want to get rid of that, but since I was going to do it one way, I just figured get rid of both of them. So now it's just completely modal, and the way that I have that work is I can go in and out of the mode, and you can see I changed the color of things on the screen to say which mode I'm in. So right now, if it's white, I'm in that mode of just typing in keys like you would normally. But then if I leave that mode, now I'm in a mode where I can issue commands like undo or something, or build. And that's all that's happening there. So you'll see those things change from a color, and that's all that's happening there. So again, it's a little bit different than what you're used to, but otherwise, there's really no difference. The operations are all the same. I haven't, like I said, even gone in and tried to take advantage of that modality, so you'll literally see me doing the exact same operations I've been doing in Emacs. The only difference now is I'm doing them modally instead of with the modifier keys, and to that end, you'll have to cut me some slack for being a slower editor now, because since I've switched key bindings, it's like, I have to kind of relearn it. So things will go a little slower than they used to, I suspect. But other than that, that's where we're at. So if I remember correctly, and it's kind of hilarious that I would even remember correctly, considering that it's been a month, where we sort of left off on is I decided that it was a good time to sort of have hardware acceleration in the game. So we have our software renderer, which of course we wrote ourselves, and which kind of surprisingly, at least to me, ran very quickly. It could even run the cutscenes reasonably, if not great. So we never really had to address the need for 3D hardware acceleration. But then we were sort of like, well, it's probably time when we're going to do game tuning. We'd like it to run at 60 frames a second all the time without us having to stop and optimize our software rasterizer all the time, or things like this. So, maybe it would be nice if we had the ability to access hardware acceleration. So we did OpenGL implementation. And we pretty much did all of the stuff to implement OpenGL for our purposes, which is actually, very simplistic. There's not very much work that has to happen to do that, which I kind of showed. It's just not particularly involved. But what we did not ever do is we did not ever actually finish texture downloads as an actual first-class citizen. So what happens right now is the texture code is just kind of placeholder. And this means two things. And I'm going to go over them on the blackboard so that you can understand what they are. And then there's one thing with getting sRGB that we'll probably do today as well. In fact, you know what? How much time do we have? So we've got, I guess we're about 15 minutes in the stream, so we have about 45 minutes. So I'm trying to think of which way we should go, because it probably won't take 45 minutes to get the RGB stuff. I'm gonna do the texture stuff. I think that's probably a better idea. So I'm just going to really quickly just explain what was going on with the textures, and because people probably have forgotten or maybe don't even necessarily know some of the stuff that I was needed to do with them and that they weren't doing. And so hopefully we can kind of get that squared away. All right. So sorry, what was it? Day 244. Why is that? That's a weird color. There we go. All right. Okay, so what was happening beforehand, right? And you're going to have to kind of pull back into your memory or pause this and go rewatch the videos if you don't remember. You're going to have to pull back into your memory the GPU, conceptual GPU stuff that we talked about, right? And specifically, you're going to have to remember the stuff about the fact that there was GPU memory and CPU memory. And these were not necessarily the same thing, right? Especially when you have a discrete graphics card that's plugged into a slot, the GPU has a set of memory chips that are totally its own. It's not even remotely in the same physical location as the CPU memory. They're totally separate. And so what happens is, we go from the disk, we load a texture into CPU memory, but that is not accessible by the GPU. The GPU is over here and has to be able to read out of this. So we need to get the textures onto the GPU somehow. They have to be moved over there. And so there is a degree, like we talk about immediate mode versus retained mode, things like this. There's definitely a degree of retention that happens with GPU programming for this very reason. We cannot send the whole texture down to the GPU every time because it could be huge, right? A single one of our plates for the cutscene could be something like 6 megabytes when uncompressed, right? That's just a lot to send down every time if you're talking about lots of these different plates that have to go down there, right? And so we don't want to just spend all of our time and all of our bandwidth to the graphics card, sending down the same textures over and over again, it would drastically limit how much textures we could actually use in a given frame, because instead of it being about how much memory is on the graphics card, it would suddenly be about how much bandwidth can actually go to the card during a single 60th of a second. Not what we want. So, in pretty much all ways, you can think of that GPU memory as sort of like a cache, right? It's a lot like the way we think about the cache on the CPU. When the CPU is operating on something, you want to have all of that stuff there in the cache so that when it's operating on it, it's nice and fast. It doesn't have to go out to main memory to get it. The same is true of GPU memory. When you're drawing a frame, you want to have all of your textures in GPU memory. That doesn't mean that all the textures for your game are necessarily going to be in GPU memory, because you may have too much textures, like too many actual images, to even fit. Like maybe you have 2 gigabytes of images, but the GPU is only 1 gigabyte worth of RAM. Well, obviously, that's not going to work. So it's very much like a cache. You're trying to put the textures that are relevant to the current time in the game, the current 20, 30 frame horizon. You're trying to make sure all the textures that are necessary to render that set of frames are actually on the GPU in time for it to work with them. And in order to do that, what we need to do is have some opinion about what textures need to be in GPU memory, and then have some concept of how to get them down there, or at some point when they're no longer necessary, remove them to make room for another texture. Okay? Now, to a certain extent, like a regular cache, GPU memory can be sort of virtualized in the sense that you can oversubscribe it, right? Meaning I could, if this was 1 gigabyte, it's entirely possible in certain circumstances, and given the way that OpenGL is specified and stuff like that, I could, for example, create 4 gigabytes of textures and tell it to the card. And if I did that, what would happen is the driver would sit there, and it would basically try to do a sort of best guess of which quarter of this 4 gigabytes it was going to put on the card. And then when we inevitably tried to reference a texture that wasn't in there, it would pick somebody to evict and then pull somebody else in. So it really does work a lot like a cache when the driver sitting there will actually start acting like a cache. That'd be fine if this were an application like 3D Studio or something like that, where we don't care about hitting a hard frame limit. But when we're talking about wanting to render 60 frames a second and not have a bunch of stuttering happening all the time, we want to make sure that the driver is not doing that. We want to make sure that we are not oversubscribing the texture memory, and that we are knowledgeable about when our textures are going to be used, and that we get them down there before that happens. So that we're not in a just like, oh, darn, I'm using a texture that I didn't know about yet, right? Or that I need to get down there. So that's something that we have to do. Now, unfortunately, graphics cards don't make this easy for us. And this is a little bit of an unfortunate scenario, which is that this sort of swapping where the driver swaps for you, unfortunately, is actually more efficient in a lot of ways than if you try to do it yourself. And the reason for that is because you don't actually know the format in which the driver needs to store the textures in order for the GPU to actually use them. And what do I mean by this? Well, there's something called swizzling. And we've sort of used this term in the past because swizzling just really means rearranging things. So in some sense, when we were talking about SIMD programming, right, we would talk about things like, oh, there's 4 lanes of this SIMD, and maybe like a typical way of using the word swizzle might be that I'm going to like rearrange, some set of these things. Like this is going to be a swizzle where I do CBAD or something, right? Where you kind of have CBAD, that's my rapper name maybe. So like you can sort of see here, I start out with some ordering of things, and then I rearrange the order of those things to give me some new order. That's often called swizzling. Well, swizzling happens for textures too. And the reason that swizzling happens for textures is because graphics cards are not set up to actually to be optimized for the case that we actually are talking about in Handmade Hero. In Handmade Hero, we're talking about a bunch of 2D cards stacked on top of each other, right? And the hero is one of those cards, and trees and stuff are one of those cards and whatever, right? And we're always talking about using the entire texture in the order that it was drawn in, exactly as a rectangle on the screen, right? That's what we're essentially doing. And so the degree to which you would need to do swizzling to support that kind of operation is probably not huge. It doesn't necessarily mean that you couldn't do some swizzling to help, but we'll get to that in a second. However, the point that I want to get to first is just that what they're normally trying to do is they're normally trying to take, like a triangle, and a triangle is like assigned to some region of this texture, right? Like texture mapping in the traditional sense is pulling out a region of this and putting it onto a triangle that's from a 3D model, right? So they're very much pulling from little sections all over the texture, that really don't have anything to do with using the whole texture. In fact, a lot of the times, there's no way the whole texture would get used because part of it's on like the back of something that you can't see the whole of the texture on one frame, et cetera, et cetera, et cetera. There's just tons of reasons why a texture is not getting accessed in the same way when you're talking about just stamping it down on something versus when it's wrapped on the surface of a 3D model for actual texture mapping. So, in order to best support texture mapping, textures are often swizzled in such a way that if you were to take the original texture and you look at it like this, I've got the little hero on here, here he is. The actual way that it's stored is some totally other way. Like, in memory, we think of this as a row, right? And we think of this as maybe like 0. I guess we did it bottom up or something, right? This is how we stored it. So like here's the pointer to the first pixel, and they go all the way across this row, and then we come back up here and go all the way across this row, right? That's how it's stored in memory. So linearly in memory, you'd be reading it this way, right? I mean, we all know this. We wrote the routines to read and write them. We implemented all that, right? That's what we did. Well, if you think about what happens when you're trying to talk about a little square here that might map to a particular triangle, right? Something like this. If that's what we're talking about, and we're not typically processing huge runs of things like that, then if you think about it, the cache coherency of this texture is not particularly good. If I'm only going to talk about grabbing this much of a line, typically when I'm operating on it, then what I would rather do is have it more look stored like this in memory, right? Like maybe little squares of textures, right? That were maybe like 4x4 or something, so that when I load 16 pixels, instead of loading a big long line of 16 here, I'm instead loading a little square. Because the chances of me using everything from that little square when I do that load are much higher, right? And furthermore, I probably am going to use things in this area, right? Like if I'm looking at this image, I'm probably going to use a bunch of things in this area if I'm using something in this area, but I might never use anything in this area, right? If I'm going to use a bunch of stuff in this area, I might never touch this area. So they also tend to continue swizzling to pack blocks instead of going in memory this way. They might go like in this way, like this block, then this block, then this block, then that block, then this block, to try and again maximize the chances that we're hitting things in the same. If we're pulling, from different regions, it's easier for the memory controller to grab these things out. Now, to be completely honest with you, I have never studied texture swizzling at all. Like when I worked on Larrabee, that was just something I never actually saw. The texture unit stuff, I did not know how they did their swizzling, and I never really looked into it. So, unfortunately, I can't tell you any more than a hand-wavy explanation like that, where I'm like, they're trying to rearrange it to make memory access and computation easier on the critical path, which is sampling textures for triangles. How that actually breaks down, I don't know. Like, I couldn't tell you the hard proof of here's exactly why, here's the exact format they're going to store, and here's why. I don't even know if it's the same from card to card. I suspect it probably isn't. I suspect there's different swizzle formats depending on which graphics card you're on. Anyway, what that means is when you submit a texture So you have a texture you load off disk, and then you hand it over to OpenGL. What's actually going to happen is OpenGL is going to swizzle that texture. Now, maybe that texture gets swizzled on the card. If the card has some way of swizzling the texture on it, meaning it can do the remapping, but maybe it doesn't. And so what that means is the CPU itself actually has to rearrange all that memory at a very expensive cost, right? It has to actually go touch all that memory and move it all around. So what that means is if you've submitted a texture to OpenGL, even if it didn't go to the card, it has gone through the swizzling stage and could remain in memory pre-swizzled, which saves time on the transfer because instead of having to swizzle and then transfer, it just has to transfer memory that's already been swizzled. So, unfortunately, even though we do want to get rid of this because it's a bit unpredictable, we do lose something because that how to swizzle the texture is not exposed to us. I wish it was. I wish they had formalized that sometime in the past couple years and said, here is how everything will be swizzled so that when you do your own stuff on the CPU side, you can just submit pre-swizzled textures. I don't think they have. Even if they have, plenty of graphics cards in circulation don't have any sort of thing like that. So I don't really think there's much you can do, at least at this stage in the game. But, okay. Now, we may get away with not having that because we are using rectangular textures, which tend to be treated somewhat differently in graphics cards. Square textures are the more common thing, or more particularly not square or not rectangular. I should say power of 2 and non-power of 2. So most textures that you would use on a graphics card for mapping onto a 3D model are power of 2. And what that means is simply that the sides are a power of 2 in length. So if I was to, draw you one of these, it would always be like 256 by 256 or 512 by 256, right? So it can be a rectangle, but just the actual dimension is 2 to some power and never anything else. It's never going to be 540, right? It's going to be 512 or 1024, but it's not going to be this. Originally, that's all that graphics cards supported. Originally, graphics cards could literally not do any other shape. Nowadays, they do, and certain ones support it more than others. Like some actually secretly end up using a power of 2 texture anyway, and just don't tell you about it and the space is wasted. Other of them I think actually do, but either way, I want to say that the rectangular texture paths nowadays don't go through the same kind of swizzling. And may not have as much of a cost associated with them. And the reason for that is, of course, that they are expecting it to be something like a video download or something where you're trying to send over a thing that you're going to rectilinear blit, and you want to try and A, save the time on the submission, and B, you're not going to be wrapping it onto a 3D model anyway, and blah, 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 blah. I don't know. That's all minutia that only people who follow GPU stuff very closely could tell you. And, if there's someone on the stream who happens to be a GPU expert that's up on the way that they currently work, they could fill you in. If not, none of this really matters too much for what we're doing. This is only if you're going to be one of those people who's a serious GPU programmer. All of these things are things that you should know, right? If I was a serious GPU programmer kind of guy, I would know these things. Or at least I should say, if I had a GPU person on my team, I would expect them to be up on all this stuff. If you're a generalist, and you don't have to deal with squeezing every bit of performance out of a GPU, then you really don't have to know this stuff. But it's good to be aware so that when the time comes and you do have a little something that needs to get tuned or whatever, you kind of have some idea of what's going on. And then you could ask the specifics. You can ask someone from NVIDIA, someone from ATI, whatever. You can say, hey, yeah, I kind of remember the rectangle texture thing, and I was wondering, what's going on in there? They don't seem to be downloading as fast as they could. Is it a swizzling problem? Just having an idea that something like that might be happening is really all you need to probably know as a generalist, if that makes sense. Okay. So that's essentially the situation. And so what we have to do is figure out a better way to deal with this than what we're doing right now. Because all we're doing right now is when it comes time to draw, we just look to see whether we've ever submitted a particular bitmap that we have in our asset store. If we've never submitted it, we submit it and we draw it. Otherwise, we just use the handle that we've used before. There's two problems with this, and they both need to get fixed. Problem number one is it's just too late, right? Meaning we only do this when we actually go to draw. So if we have some huge texture here that's some 20 I don't remember what they were. Oh, they're 1920 by 1080, right? Or more, right? So we have some big 1920 by 1080 graphic that was for the cutscene that we want to draw here, right? It's like the house or whatever. I don't know what it is. We want to draw that. We see, oh, it hasn't been downloaded. We download it right there and draw it right there. What that means is it creates this sort of bubble where the graphics card can't start rendering the current frame that it's supposed to be rendering, that we're like, we need you to render this right now. It can't start rendering that current frame until after it finishes downloading this gigantic 6 megabyte texture or something. Now that's a real big problem and it actually might be an 8 megabyte texture. I don't remember how much that is. How much is that? 1920 by 1080 by 4. 8 megabytes. So we send down this 8 megabyte texture, and we're sitting there waiting for the graphics card to transfer it before the graphics card can ever even start rendering that frame. And that's no good. What we would rather do is we'd rather have the graphics card be transferring this while we're drawing frames we do have the textures for, such that when we get to a frame where we don't have the textures, it will have had that whole time to put it in, and hopefully by the time we get to that frame, the texture's there. It's exactly analogous to what we were doing with our assets where we load them off disk, and this is just another step in the process. So before, we had a thing where we've got the disk version of the texture, we've got the memory version of the texture, and then we've got the screen, right? And we were just like, okay, disk fills to memory, memory fills to screen, this is instant, and we do it on every frame. This takes time, so we overlapped it on a thread. All we're talking about now is essentially there's another step in this process, right? It's the GPU. We've got to get the texture into the GPU, or we could open the Windows Start menu. Always fun. Yeah. So we've got to get it into the GPU, and this is also not instant. So what we want to do is, if possible, put this on a thread as well. So that's what we're trying to do. Now, there was a time when this was more or less impossible. Like if you tried to thread a texture download, heaven help you. It was not going to work. Don't try. Disaster, and off you go. Nowadays, most people try to stream textures down to the GPU dynamically because essentially it really reduces load times and also drastically increases the amount of detail that you can have. Because obviously you can have a 27 gigabyte game or something like this where you're free roaming around. You need to be updating these textures because the graphics card might only have 512 megs or a gigabyte on it, right? And a lot of that's taken up with textures. So nowadays, while it's not easy to ship anything on a GPU in Windows because you have tons of driver compatibility problems anyway, while it's not easy to ship threaded texture download, it's not so much more difficult than anything else to get right, which is to say that it's not that hard potentially to get it working on your machine, and then when you go to ship it on Steam, everyone and their grandmother has a problem with their 12-year-old driver and their weird graphics card that they overclocked and everything else, right? So now on the PC, it is generally possible to thread on most systems, and you are not necessarily opening yourselves up, as far as I know anyway, in my understanding, you're not opening yourselves up to drastically more driver compatibility bugs than you already were going to have anyway. However, unfortunately, that number is still probably quite high because, yeah, drivers and Windows. Drivers and Windows. They conspire to help you. So anyway, that's the situation as we kind of have to deal with it. That's the primary problem we have to solve. The secondary problem that we had to solve, and we'd pretty much get this, I think, for free by anything that we do that addresses this, is that right now we're never removing anything from texture memory. And what that means is that depending on how much texture memory you had, we're just going to keep on filling it up. And eventually we might overflow it, or worse yet, right now we have an eviction scheme for our CPU memory for textures, right? Like we're loading in various bitmaps from the asset store. When we evict an asset from the storage, we never go back and delete its corresponding texture, right? Because we just did the little hack to get this working, right? So what'll happen now, and like I said, we don't really have to think about this as a separate thing. I just wanted people to understand it was happening. Because when we do this, it would fix it. But what's happening right now is we have a fixed size CPU asset store, right? And then we have our GPU texture memory. So what'll happen is we'll fill, texture A will come in here. We'll do fill, here's the disk that is coming off. Texture B will come in here. Texture C will come in here. And every time we're drawing, we're sending these down to the GPU if they're not there, right? And they're not. So they all go down. Now the next time we draw, if we're still drawing with A, B, and C, that's all great. But now we get D, right? Here's A, B, and C, and D on disk. Now we get D. Well, D's got nowhere to go because the CPU cache is full. There's no room for the asset anywhere. So it might decide, well, okay, we're gonna, we have that least recently used kind of thing going on in there. So it's just like, let's just get rid of B because we don't need it. We're not going to use it. We haven't used it for several frames now. Let's just get rid of B and we'll put D in its place. So B gets removed and D gets put in its place. Our CPU side memory stuff works nicely. We debugged it and it works. So that just happens. But it never tells the GPU that it did that. So this is still here. So when D comes in, it gets added to the GPU memory, which eventually, just keeps filling up that GPU memory till it's completely out, if this was where it was. Now the driver has to keep backing store of this thing, which further fills up main memory until all the main memory is gone, and then you're just done. You're just out of texture memory and you'll just get gray images or something, right? So we have a situation that would be untenable in the game right now anyway. So at a bare minimum, if we wanted to ship what we have now without doing something that was a little more coherent for prepping the GPU, we would at least have to add something to our asset code that said whenever we evict an asset from the CPU side asset store, we also have to evict it from the GPU side asset store. Which brings us to one more point that is probably worth mentioning. So right now, if you remember, the way our CPU asset store works is it's essentially a general purpose allocator. Like it just puts things in, and then when it frees something, it remembers that it's free, and if you free enough stuff again to make space for another asset, it'll like use that up, right? It'll then put something in there. But that's what we have right now. And it's not particularly well implemented, right? We put it in there and I said, this is just a basic thing. This is not a very good allocator. We're going to save this till we actually have some performance stuff to run through it. And then we'll see if there's anything smarter that we want to do there. Because again, you don't really want to over-engineer something like that because you don't know what its demands are. And if you try to over-engineer it before you're actually running your game through it, you might make bad decisions and you have to throw away all that work because it turns out that what you did was not smart. It doesn't solve the problem that you actually end up having. So you don't want to do something like performance optimize your CPU asset store until you actually know how you use your CPU asset store. Kind of obvious basic programming principle. Premature optimization is the root of all evil, I think is the Knuth quote, perhaps. And that is sort of what I'm saying here. It's like you don't want to start optimizing something until you actually know, A, whether you need to optimize it, unless you're just trying to do it for fun, in which case, fine. But more importantly, if you are going to spend the time optimizing something, even if you are just doing it for fun, you need to pick the point in the project where you actually have the data that you can use to optimize it properly. And we're nowhere near that, right? We just don't even know. Until the game is like totally running and you're actually playing it and doing whatever, you don't want to do something like that. So that's what our CPU asset store is. The GPU asset store is obviously also a general purpose allocator. The GPU, the driver, micromanages this, right? And like uses regions and the same sort of stuff that we're doing here. If we did not do any software rendering, we could turn our CPU asset store into a fixed size free list based allocator, and it would be 100% efficient. Because all it would have to store is the handle that the GPU gave us back for where we put the actual texture. So, what that sort of means is if we want to, in the future, if we don't care about how well our asset store performs under software rendering, because at the end of the day, software rendering is purely an educational feature. Like, we don't really need it for anything. We're always going to run through a GPU if it's there because it's going to be faster, right? What we could decide to do is change the CPU asset store to actually just be a fixed size allocator that just holds the handle for the GPU side. And then what we would do is just use like virtualloc and virtual free at the OS layer to allocate and free the size of our things if we are on the software renderer, because since we don't care, that means we don't have to bother actually doing any sort of optimization for that thing. So in some sense, that might be the right thing to do, and we might want to eventually do that. And the reason for that is you don't want to stack a general purpose allocator on top of another general purpose allocator. If the driver already is going to do it and we can't stop it, we might as well, right? So that is that. All right, so I think that's just about everything that I wanted to say about texture downloading. So what we need to do now is put ourselves in some position that we can start to download these textures on a separate thread and then use them in the main thread, right? So we need some way of sort of getting that filling to happen. And thankfully for us, we already have our loading threaded, and we know that every time we load a texture, we want to send it to the GPU. At least at the moment, that seems like something that we would want to do. Because if we thought we were going to need it, we pretty much want to get it to the GPU as fast as possible. So what we can do is just start to look at that code and see if we can formulate a good plan for how we're going to make that start to work. We only have 15 minutes left, so we're probably not going to implement very much, but as with anything on Handmade Hero, anytime we're about to do a complex topic, we kind of have to spend some time on the whiteboard so that everybody's on the same page and you know what we're about to do, instead of just seeing a bunch of code whizzing around. All right. Here we are in handmade.cpp. Kind of good to be back in the code base. And if you remember properly, we had this OpenGL file, and here is where that stuff that I was talking about actually takes place. So if you look in here under render entry bitmap, you can see what I'm actually talking about when I say that we just kind of did this just-in-time hacky thing. Like I said, you may not remember it. But GL bind texture here, this is the thing that says we're going to be drawing with this texture, and you can see that what it is predicated on is the fact that the bitmap that we're going to draw has a handle associated with it. That handle is the thing that the driver gave us back when we submitted it. So if we have one of those, we just bind it and say, hey, graphics card, you already have this texture. We're going to use this texture to draw in a second, so get ready. On the other hand, if we find that there is no handle, that means we have to actually bind a new texture and send it down. We ask it to do that, and then we submit the texture. So this is actually right here the part that I'm concerned about. Again, there's the part about never freeing them. That's obviously something that's separate. But what I'm talking about when I'm saying overlapping the texture download, this is the part we're talking about. This text image 2D is taking the memory for our texture. So all of that stuff that we loaded into memory off of the drive, we're trying to submit that down to the graphics card. And we don't know how long that's going to take, and we want to give that the most amount of time it can. We don't want that to potentially cause a hiccup if we have to do a bunch of these. We want those to be overlapped. And what we also know is a lot of modern graphics cards, everything probably from a GeForce 500 model and up, for example, around that time period. So quite some time ago. I mean, they're on like GeForce 900s now, right? Or something like this. So quite a while ago. They have things on them called copy engines, and those copy engines are actually pieces of the graphics card that do nothing other than transfer stuff like textures over to the graphics card asynchronously while the graphics card is doing other things. So we know that there's plenty there for us to take advantage of, and that we are not like interrupting the rendering of our frame by asking the graphics card to do this transfer on lots of different modern hardware. It's actually set up to do exactly this. So what we want to do is figure out a way to move this GL text image 2D out to somewhere where it can actually happen in an asynchronous fashion. And this is going to turn out to be a lot more difficult than you might think, and a lot of that has to do with the fact that the OpenGL API was not designed with anything like this in mind, and so the way that you end up doing it is kind of a little bit janky. But, so, back to a little bit more of a refresher. if we go into our handmade asset.cpp, then you know that we've got sort of this this concept here of the asynchronous loading, and you can kind of go in and see we've got like load bitmap here, right? And this is the code that gets executed when we need to load one. You can see what happens. We say, oh, okay, I need you to like to sort of create this job, like this sort of work structure, we called it, right? Like load asset work. And here's all the information you need to go get off of our out of our asset file. Here's this information you need to go and load that asset, right? And so then it dispatches up to here to load asset work directly, I believe is the actual dispatch, right? Because here's the load asset work, and it just calls that load asset work directly. So if we look at load asset work directly, we can see what happens. All it does is first it reads the chunk out of the file that we wanted, and then it looks to see if it was able to do so, what would it actually need to do in order to finish making this asset like usable. And you can see that for a font, there's some stuff that it actually had to do. So we were already in a position to say, if this was a bitmap, do some extra stuff, like submit GL text image 2D. So we put ourselves already in a very nice position to write this code properly. Because what we can say here is like, I want you to do a finalize asset, texture on this thing or something. We'll call it image or bitmap because I think we want to just keep using that terminology rather than use the graphics card one. But if I come down here and say like, okay, in this case, I've got another thing that I want to do when I have to finalize something, then what I need to figure out is some way to move that GL text image 2D over here to this other thread. So in a world where we didn't have like all this driver complexity and whatever, we would be able to do exactly this, because if you look at it, we've actually got essentially all of the information that we need, right? There isn't, like, we have the width, we have the height, we know it's BGRA, we know it's unsigned byte, we have the memory, so we have everything that we had here, right? That's all the same. And the GL, I forget what it is, the GL, where is that thing? There's default internal texture format. Let's see here, default internal texture format, yeah. That's just some arbitrary thing that we defined. And so we just need some way of like passing this piece of information down about whether or not we want it to be sRGB or RGB, right? And that just depends on whether we saw the extension. So we have one piece of information that we'd have to conduit in here. That's not particularly hard. It's something that gets set once. There's actually no race conditions accessing it, so it's threaded access to a thing that's essentially constant. We don't have to worry about it at all, so we can fix that no problem. What we can't fix is the fact that this GL text image 2D has no notion of where or when or why it's executing. Because if you remember, when we talked about how OpenGL works, there's essentially a OpenGL context associated with every thread. And when you issue one of these calls, like GL text image 2D, what it's doing is it's looking up in the thread local storage what context that is and executing the things on that context. OpenGL does not allow the same context to be active on two threads at once. So the main thread, which is calling these GL these GL drawing operations, cannot be using the same context as this. So we can't just call GL text image 2D right here and expect it to work. It will totally fail, right? It will not work at all. And just to kind of underscore that, I'll go ahead and show you what I mean. I guess we also probably want to do this, huh? So let's say we move all this stuff out there, right? This is all going to be out there. So when we come through here, we would just do, instead of this if entry bitmap handle stuff, we would just always bind the bitmap handle. We just always bind it. If it happens to be 0, that just means that this texture isn't there yet, which means that we won't draw anything, which is fine. That just means the asset wasn't there, we missed the cache, what are you going to do, right? We could choose to stall at this point, right? We could choose to hold the frame. To do Casey, hold the frame if we are not ready with the texture. So we could choose to do that in the future if we want to, or we could say 60 frames a second is more important than having everything last thing draw properly, so just don't. And just always go. Right? We could do that. But then the code essentially looks like this. And now this code is over here. So, again, two problems with this. First problem is we don't want to be calling GL code in the middle of our code path here, right? Because for all we know, we're not even running on OpenGL, right? So we want to have something here. We need this to be a little more clean, and we need this to be a little more platform separated. We had all our OpenGL code kind of isolated. We want to keep that being true. So really, what we're going to have to do is sort of pull this out and make it a little more isolated first. That's obviously going to have to happen. But beyond that, what we need to do is figure out some way to make an additional, to make an OpenGL context that this thing can actually use to download the texture. So we need to do that as well. That's what we need to do, and we have 7 minutes, so forget it. It's not even remotely going to happen, but we can start. We can get a little further. So let's talk about what happened in here. I don't know if we actually put the make. I don't think we did, right? Because the wiggle code should be in Win32. Yeah, here we go. So Win32 handmade.cpp. We have the wiggle make current, or we should. Oh, wait, that's the H file. My bad. So wiggle make current. Here is wiggle make current. You can see this is our OpenGL startup code. And so what we did with the OpenGL startup code is we said, all right, we need to create a context. And then we did what was called context escalation, at least what I call context escalation, which is saying when, and I'm not going to explain all that again because we have whole episodes about it. But basically, we start out with an OpenGL 1.x context. We want an OpenGL, a more modern one, OpenGL 3.0. So then we escalate to an OpenGL 3.0 context. And off we go, right? Now, when we did this, I sort of hinted at the thing that we would eventually have to do, which is that when we do this wiggle create context attributes arb, right, you can see that there's this thing called the share context. The share context is saying, when I create a context, I may want to create another context who shares memory with this other context, so that if I download a texture to one of them, it's accessible in either. And that's exactly what we want to do. So all we need to do to start setting ourselves up for calling GL text subimage on a separate thread is make sure that any thread that could call GL text image 2D has a context that is shared with our context. And then all of them can be downloading textures, and we wouldn't necessarily have a problem. Now, whether the driver freaks out if we have 4 threads trying to download textures at the same time, I don't know. We're certainly going to find out. But there's no technical reason why we shouldn't be able to do it. And if the driver is written properly, then that would work. So if we take a look at when we do our create thread, and I'm sorry that I'm jumping around here a little bit, but a lot of pieces come into play here, so I'm just trying to give you what they all are. You can see that when we do a Win32 make queue, you ask for a thread count, and we go through each of the threads creating a new thread, which goes ahead and calls into the thread proc. And that thread proc is the thing that sits there and waits for a work queue entry every time that it basically sits there waiting for work to do. Now, when it gets work to do, it will do that work. And when it does that work, one of the pieces of work it might do is to call through here and call finalize asset bitmap, which means that any thread that is created on our work system needs to have an OpenGL context associated with it. Otherwise, the GL text image 2D call will fail. So what we need to do here before any thread proc actually goes into service, we need to make sure that it has created its own context. So we need to do something here like Win32 create OpenGL context for worker thread. Once we have that, then these threads will be able to perform those downloads. Now, we don't actually want them to perform the downloads directly here, like I said, because we probably don't want OpenGL code sitting in the middle of our otherwise platform-independent code. But that is a problem we can easily solve later by having this code either use something that calls to the platform layer to do the download, or we can do something even more ridiculous. In fact, this might be the better thing to do, and I don't really know. So the other thing we could do is actually just put this on a queue for another thread to download and have it pick it up. It just seems like too complicated. So I feel like this is probably the better way to go, and we'll see. All right, so what we would do is we'd say, hey, create an OpenGL context list so that we know that it's already set up for that. And then when it comes through here to finalize bitmap, it knows that it will always work properly, right? Okay. So let's go ahead and see what we would need to do for that. So I'm going to go ahead and take this guy here and take a look at that wiggle make current. So here we are. And here's our Win32 init OpenGL. So what we need is essentially another one of these, right? We need one of these, excuse me, where all it's going to do is it's just going to do this, right? It's literally just going to do just this one part right here, and that's all. Oops. Like I said, you have to bear with me on the editor. I'm still learning the modal, like I'm still learning the modal ropes, if you will. So Win32 create OpenGL context for worker thread. It just needs to come in here and do exactly this thing, where instead of passing the share context as 0, I'm going to actually say that you just need to tell me what that share context actually is, and then I would be all set, right? We would just do exactly this, and off we go. Now the window DC part, I don't actually know whether we need to ever pass this window DC. We certainly could pass the window DC, but since this context can never draw to a window DC, I don't actually know if it's more appropriate to actually just use 0 for it. I couldn't tell you. I feel like you would probably want to do something more like this. And again, I'm not 100% sure, to be really honest with you. So what I would say is we probably want to check for example, I have a particular presentation in mind. And we just want to see what they would recommend. Because basically, anytime you're programming a GPU, you want to see what the graphics card vendor people say, because that's usually the best option, right? So let's see. So to them, it would appear that they want to pass the WinDC, right? And so because that's what they're saying, I'm just going to assume that that's the right thing to do, and that it sets it up in the right position. This, by the way, is a presentation specifically about the copy engines on the Fermi and up, which you could look for if you want to know more about asynchronous texture transfers. Right? So anyway, so we do want to do this. We do want to have the WinDC in there. So we're going to have to pass those two things to this, which means that we actually need some way of getting them. Now, we know that we can always get the DC of our window. So in theory, we could even save the DC of our window, because if I remember correctly, we actually use CS own DC. So we actually always have the DC of our window anyway. But point being, if we do this, if we have the WinDC and the share context, then all that's missing is those attribs. So these attribs, we can just move out, right, and save them, because we know we want them to pretty much always be the same, I think. So if I just put those guys out here, and we call this, Win32 OpenGL attribs, we can just make that be something that everyone has access to. It looks like I'm out of time, so we'll probably have to stop for today, which is fine. All right, so we've got our Win32 OpenGL attribs. This down here should also be the Win32 OpenGL attribs. And I think that's pretty much all there is to it. Now, if the wiggle make current doesn't succeed, then there's really nothing we can probably do about that. I mean, if for some reason it doesn't want to create another one for us, I think this is probably just going to be like a fatal error scenario. I mean, the game just, if we can't get a download context, there's really nothing we're going to be able to do. I mean, we could try to engineer some kind of crazy backup path for it, but on the whole, I think it would be pretty impossible. So anyway, this is really what we need to do. And once we have this, such that we've got our OpenGL DC set for every one of those contexts, we're pretty much good to go. So we just need to save these pieces of information. I think we might have a global window handle. I can't quite remember whether we do or whether we don't, though. Do we? Let's see. I guess we don't. So it looks like we never actually store that, unfortunately. So what I guess I would say is maybe we want to just go ahead and be relatively careful about this and go ahead and pass it through a little more cleanly. So what we would do for that is where we call create window ex, which is here, you can see us creating our window. Now, when we create our queue is a little bit earlier. We've got this test code up here, and we do our make queue stuff. What we can do, I believe, I don't think there's really any reason that we would need to do it at a different time. So I believe what we could do is move the queue creation down such that when we make the queue, we could have the window handle ready. So when we create this window, we could go ahead and create the queues afterwards, such that when we create the queue, we are in a position to pass the window actually to it. And we could even initialize the OpenGL. I guess I don't know if we can initialize the OpenGL after or before or after the toggle to full screen. I think we could do it at either time. But yeah, I guess we can even move this down even further, right? So we've initialized OpenGL here. And when we initialize OpenGL, we could just pass the HGL RSC. This is the OpenGL RC. And then these guys can get that passed. So when we call make queue, in this case, I believe the low priority queue is the one we're concerned about. There's two of them. And so here I can pass the OpenGL RC and the window handle, like so. And this one could just have those be sort of nullified out, if that makes sense. So that would be the signal that it doesn't ever actually need to do that. And off we go. So let's say that that was true. In fact, I know I'm over time here, but we haven't done Handmade here in a while, so I feel like I'm entitled to a little extra programming time. Let's just do one last thing. So all I wanted to do here was say that when we actually do create that, so when we do our Win32 make queue, obviously the thing that has to do the wiggle make current is actually this thread proc, and we have this parameter, which is the platform work queue thing that has the queue on it, right? It sets this stuff up. That's the thing that we actually want to probably put the data in, right? We probably want to put the data in there. The platform work queue, though, I guess is not really a Win32 thing. I don't think. It's not defined in the Win32 layer, if I'm not mistaken. Like platform work queue is not a thing, if that makes sense. So what we probably want to do is actually extend that notion a little bit and say that there's actually another piece of information there, right? Another thing on top of it. And so what I'm going to do is say, okay, there's struct Win32 thread startup or something like this. And in there, we'll have stuff like platform work queue. But then we'll also have the window handle and the OpenGL RC. There we go. Make sense? So that's our game plan anyway with that. And so then when I'm in here, I can make one of these guys, Win32 thread startup, and I'll just call this thread startup. And in this case, we'll just pass the thread startup code with nothing in it. And in this case, we'll pass the thread startup code with something in it. There we go. So we've got thread startup dot window thread startup dot OpenGLRC. So now we're in position to excuse me. I don't know why I feel the need to type that whole thing in. Now we're in position to have this guy fill out the startup structure. So basically, if startup, and in fact, we know we always need one. So if we're past the startup init, you know what? I think we were always past one. Never mind. We were always passing one. So now when we go ahead and do this whole queue thing, right, and we pass the platform work queue thing there. Oh, and now that I think about it, I guess this stuff actually kind of comes in like automatically. So we don't even need that part of it. So the queue can just come off of the startup, like so. And then that startup will just get passed through directly. So instead of passing the queue handle here, we pass the startup, and excuse me. And then when the thread block actually does this and it gets the LP parameter thing out here, then that LP parameter is actually a Win32. What am I looking here? It still has to. This still has to be. There we go. I have to make it so that we actually use a fixed one because obviously each time through the stuff's going to get grabbed out of there. So it actually needs to be different for every thread, if that makes sense, because we don't know that it's actually gotten the information out of there yet. So in order to pass that extra information through, boy, this tends to be a real pain for passing this information through. I feel like this actually introduces more bugs than I thought we were going to save by doing it, because I would actually need each of them to have their own one, otherwise you can't go changing it, right? So maybe that's actually dumb, now that I think about it. Maybe we don't actually want this to be the case. Maybe that's just stupid. And maybe the better way to do it is just to say, like, hey, those are actually just global latched variables, if that makes sense. Because all of a sudden, it seems like that's actually a lot uglier, if that makes some sense. So here, if we did something like, before we make these work queues, we say, like, global OpenGLRC equals Win32 init OpenGL. And like, you know, global DC equals get DC window. That's probably actually just ironically quite a bit safer, it seems. So maybe we will do it that way. Let's take a look. So up here, we would just define a global variable for HGLRC. What did I call it? Global OpenGL? Yeah. And a global DC, like so. And those would essentially just get latched. They'd just get set. And then when we do our thread startup, it would just work. Where's my wiggle make current? So let's see. Here we go. Create OpenGL context for worker thread. In this case, it doesn't really have to take it, either of these guys. Now they're not going to be parameters. They're just going to be here. And we'll just make this global DC, and this be global OpenGLRC. And that actually should work. And again, I don't know. Maybe it wouldn't be a big deal to pass those down. I just didn't love that. It was like, well, now it's actually getting kind of more janky than if they're just set, because they don't change. And so it seems like until we actually change them around, we don't actually want to, oops, that's HTC. We don't actually want to introduce that complexity for no reason. It just seems like a bad decision. So I just said, like, might as well not. All right, so when we call wiggle create context arb here, oh, and that's another thing. That's a pointer, so we're going to have to save that pointer as well. So let's see. Cannot convert from void. Right, so we need that guy to save it. And one thing we could do is make this stuff actually get stored, I suppose, up in Win32 OpenGL init, if that makes sense. So what I could do is say that this is actually responsible for storing it. So if I actually go back to Win32 init OpenGL right here, what we could do is say that this actually stores that DC. So instead of releasing it, we actually store it. So we say like global DC equals window DC. and never allow that to be released. And then similarly, the global OpenGLRC equals OpenGLRC here. And wiggle create context arbs is going to have to do exactly the same thing as well, right? So wiggle create context arb has to be something that we would keep so that other people can call it. So I think that's basically it. But, excuse me. All of this, of course, is predicated on whether or not we ever actually got that function. If we didn't, then we would not be able to run, right? We would not be able to run, at least not through OpenGL. All right. So I think we're good. I don't know where wiggle context. There it is. There we go. And so now I think wiggle win32 make q has some probably wrong signature here. What was I passing it? The window is not gonna get passed. That's just dumb. Okay. All right. So now we're compiling again, and in theory we can run, but of course we won't see anything now because we don't download any textures, right? So we're creating a bunch of sort of workers and stuff, but we don't actually ever download any textures, which is not particularly useful, if that makes sense. And as you can see, there's actually nothing on it. So we'll stop for today, but we're pretty far from actually being in good shape at this point, to say the least. So we have to actually go do the work of actually coming here into the asset file and actually making this actually do something. And then we have to actually make sure that we did everything correctly and that we're actually getting the context and that we're actually having those guys have what they need for wiggle make current and all that other stuff. So that actually has to happen as well. Okay, so last things last, I guess when we do our wiggle make current here, in our Win32 create OpenGL context or worker thread, we know that we only do the asset work, I believe, on the low priority threads, right? So we actually don't need to create these for the non high priority threads. So if we actually take a look down here, when we're in thread proc, we want to have some idea of whether or not this particular thread is high or low priority. So that platform work queue where we actually define that, which is in here, I believe. So the platform work queue. Is that actually defined? Oh, it's not. So who defines it? Is that actually defined in the Win32 side of things? If so, I'm going to feel pretty stupid because I just was like, well, blah, 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 and then it's not actually in the thing and whatever. So let's find out. From work, platform work queue entry, platform work queue. So it's actually right there. So actually the entire time, I could have just stuffed it in there. Brilliant. Anyway, doesn't matter. Point being, here's our platform work queue. And what I want to do in here is I want to have some notion of whether this thing is ever going to download anything like that, right? So I want something in here that's just like a bool 32 or something that's like can download textures or something like that. Because if it doesn't have to do this, and maybe I should say like needs OpenGL or something like this. And so that way, if if it wants to do that, then it's going to do that. If it doesn't, it doesn't. And I could, I guess at this point, also go in and clean up the other part of it and have it pass through there. But anyway, what time is it? 6:46. So I even have 15 minutes left, really. All right, so all I need to do is now, when I define these things, that is the high priority queue and the low priority queue and whatnot. When I do Win32 make queue on these, what I can do is just say like, okay, we'll set whatever the queue needs OpenGL thing is, we'll set that before we call it, right? So when we do to make queue, which is right here, we will just set it, I guess, before we pass it in. So let's see, to make queue on high priority queue. And I guess the high priority queue is just is cleared out to 0. So what I could say is the high priority queue, we know that it doesn't need access to OpenGL. The low priority queue we know does. So we need this to be set to OpenGL, right? So now we know that that will be set properly, so that when we do our make queue and we call into the thread code, we now know that thread code can basically understand whether or not it needs to do this. Oops. So right here, I can say if the queue needs OpenGL, then get it OpenGL. Otherwise, don't bother, right? Because we don't need it to do anything if it's not going to do that. So, so I think that's all we really need to do to make that a little bit cleaner. And now, yeah, since I kind of messed that up, I probably should have made it so that that just gets past the queue, but doesn't matter. It's all fine anyway. So now I think we're a little bit more correct. We only are creating 2 OpenGL contexts, 1 for each of those, and off we go. Unfortunately, we don't really have anything at this point that's going to actually download the textures, but we can do that tomorrow. So, we're not in bad shape. We've actually got an OpenGL, so really all we need to do is just make it so that the asset system now has a way to actually make this call. What the heck? Let's just do it. Let's just do it with a trivial callback for now, and then if we want to do something fancier, we can. Might as well. So in order to do that, right, in order to call finalize bitmap, we just need some way for the platform code to be triggered, right? We just need some way for it to actually do that download, and we just need some way for it to affect that change to the graphics card. And so in here, when we have our various stuff, we've got kind of like our our calls that we actually use. These are the ones that are only for debugging. These are the ones that we actually expect to expose as sort of like the platform for the game. So these are the actual APIs that the game is allowed to call. And we try to keep these pretty minimal, right? We try to not have a lot of stuff in here. And yeah. So I think I can actually, I wanted to actually eliminate these a little bit. I think I can actually cut down these. There's too many here that there probably shouldn't be, but so if we want to do a sort of this concept that we're going to actually submit a texture, we need a way of setting and unsetting textures, or basically like saying what's going on here. So what I think I would probably say is, let's do something like let's do something where we just have one call, and that call can either allocate or deallocate the texture, right? Something like this. So in OpenGL, we have a feed-forward mechanism. I guess the only thing is we don't, if you wanted to port something like D3D where you get back the handle and it's like an address or something, we probably don't want to do that. So we might actually want the two. But we just do, I guess, allocate texture and platform deallocate texture. So we just need both of those things to work, right? And so then the actual calls to these are pretty much equivalent to these guys here, where we'd say like, okay, we're going to give back a void star for platform allocate texture. And instead of passing a size, which is what we would normally pass allocate actual memory, instead what we're going to do is we're going to pass this information that we needed to pass down here, right? So we're going to pass the width, the height, and the rest of the stuff doesn't really vary. So then we just have like the actual like data. So we're just going to pass that down, and that's all we currently need. And we can expand this obviously in the future, but that's basically all we need for our purposes. And then we can do platform deallocate to, oops, I already had it there. So then we could do platform deallocate texture, like so. And when we deallocate the texture, all we need to do is pass back the handle that it gave us and say, like, we're getting rid of this now. It shouldn't need any other piece of information, right? Because if that's all it handed us back, so we don't need to tell it anything else. It should be able to, eliminate it with just that. All right, so if that's what we've got, then in here, after we do our platform read data from file, we should be able to do our equivalent platform allocate texture here. And we're just going to pass it those pieces of information that are the new pieces of information, like so. And we don't need this, and we don't need these. That's all we need. So with that piece of information, it should have everything it needs. And so we just need to now, on the Win32 side of things, actually place these calls actually give these calls somewhere to live. So where we've got our callback specified, I believe is up here somewhere. I don't actually know where, but it's up here somewhere if we just keep looking. So there you can see the callbacks, right, that we defined for debug. So let's do let's see, platform allocate memory. So if I just stick these guys in here, then we've got sort of our function definitions, like so. And so if I do platform allocate texture, I'm just going to call this allocate texture. And if I do deallocate texture here, then we can just go ahead and take the OpenGL code verbatim and just have it happen in here. So inside here, when we do what we're going to do, we need this to basically return a void star that's kind of the texture information. What I'm going to do here is I'm going to assign the handle to that, right? Because you know how we had that entry bitmap handle. And I don't really remember why exactly there's the entry bitmap handle thing, but point being, right, because I guess I'll just explain that in a little more detail because I kind of said that without saying what it was. When we call load, when we grab this entry here, right? That was actually code from a previous thing. That's okay. That's why I got confused. I was like, why is there an entry handle here? That's because it's a totally different thing. So when I'm going to actually finalize the bitmap, I only presumably have just the actual stuff that was stored in the work, right? Which would be the asset header, presumably, I think. So we're going to have to figure out a way to kind of store that bitmap stuff in with what we create. So if I look down where we do load bitmap, I got to remember to change search to be case insensitive, because in Emacs it's always case insensitive, and I'm used to not having to put in the correct case. So when we do this thing here, so we've prepared the bitmap, and here it all is, and there's that handle. So I think after we do asset header bitmap, we should be able to just claw that back out. Let's see, because the assets ID value, I like how we recreate that for no reason. It's right here. That's just asset, right? I don't know why we're doing that, but point being, so we can get the bitmap out really trivially. It's just like this. So the work asset header bitmap, that's the bitmap. So we can do like, and I don't remember exactly what that class is for us. I guess it's going to be loaded bitmap. So I just need to store one of those. So if I grab out this bitmap, I can store back to the handle, and now I can get all of those pieces of data that I was getting off the bitmap as well. And so now we're pretty good to go, right? That's everything we needed. So this would allocate the texture, that would do the download, and everyone would be happy, right? Everything is peachy. So in that circumstance, of course, we need to actually return the handle. And so when we do this GL text image here, I'm going to have to do the bind that would have gone with it. So the GL bind texture to GL texture 2D, I need something here that's going to be the handle. So if I'm going to do that, I need, I believe it's a GL uint, I think. I need a handle. I need some way of making that handle work. And then when I return it, I can always just cast it to a void star to return it to the caller. And I can put an assertion here just to be doubly safe. I can be like, assert that the size of a handle is, I'm sorry, the size of handle is less than or equal to the size of a void star, just to make sure that it's going to fit. But point being, we can always do that. And then when we want to deallocate here, we can deallocate. So in this case, we've already covered the thing that we would need to use here. There's a thing called GL gen textures that will just give us back a texture handle that's known not to be used, right? So we can say just give us one. It'll give us that one. We then use it. We give it back. So now it can always be used for binding and everything else that it needs to be used for. And after we do this submission, we don't really want to leave the texture bound for any reason, because this is a download thread. So we might as well also just unbind the texture so it knows we're done talking about it. Oops. Meanwhile, in here, when we want to deallocate, there's the equivalent call, which is GL delete textures, which just says, hey, that handle. So in order to get the handle, we do exactly the same thing we were doing before. We just say, oh, that thing that we passed in here, the texture that you're going to free, I know it came in as a void star, treat it instead as GL uint. Right. So this is probably one of these, huh? Yeah. So that handle that's on the loaded bitmap, which I don't actually know where that even is anymore. This is the problem with not having perm in a while. It's like, where did we store that? I'm guessing it's probably in the render group. And hey, I'm right. So this handle is not going to be one of these. It's actually going to be like one of these. And we probably should call it like some kind of a texture handle so that we know what we're even talking about here. So I might go ahead and do that and then say that anyone who references that should really call it a texture handle proper, if that makes sense, which I guess would include this dude. Oops, that's no good. What did I do? Oh, you know what I just realized? I don't really remember how to redo. Okay, there we go. Now I do. Yeah, perfect. Okay, so this handle is now texture handle. And stream actually hasn't ended. That's the funny part, Mr. Counter person. So yeah, and here we've got, let's see, hold the frame if we're not ready with texture. Yeah, so this is actually still a texture handle. Does anyone else have anything to say about that? Bind texture cannot, okay, yes, that's true. So this is just a GL uint, like so. And off we go. So in here now, we know we've just got these. We don't have to read out of an entry or anything. We cut and pasted this code from before. We know we pretty much have all this information. I think we called this the data. This OpenGL default internal texture specification is going to have to be a global, I would believe, although I guess it already was a global. So off we go. And so now in theory, we're downloading these textures in the background, in theory, right? Pretty big caveat there. We're still not actually deleting them yet, but in theory, we're downloading them. Now, here's the part where the whole machine probably crashes on us, or something equally horrible happens, but looks like not. Okay. So all we should have to do now is debug this, which might be a little tricky. And the other thing that I might want to do just before I get any further in it is when we do asset eviction, we want to call that deallocate texture, right? So in order to do that, when we actually evict an asset, which is going to be allocate game assets, and I like that we have Snuffleupagus-oriented programming written in there. When we're going to evict an asset, then in here, let's see where we've got, this is not, let's allocate all game assets. I want the actual, where's the actual thing where we evict an asset? Load font, load bitmap, acquire asset memory. That's what I actually wanted. So when we do acquire asset memory, and we do all this merge as possible stuff, so in here, when we're going through this stuff, this is the part that actually matters to us, right? So when we do remove asset header from list, we're taking this guy out, and we're changing it back to unused. Normally, we don't have to do anything, because we're in control of everything, and it's nice and clean. But in the case where this was actually a texture, we have to tell OpenGL about it. So what we want to do here is something like, okay, we're about to like free this dude, right? He's been removed from the list. And let me double check to make sure that that doesn't do anything particularly bad. So I will go ahead and say asset cpp, but remove asset, remove asset header from list. Where are you? Are you in the H file? There it is. So that doesn't do anything, so that's fine. So basically, when we remove it from the list, all we have to do is say, you know, what kind of texture actually was this? Which I guess, now that I think about it, that might be, is that something we even know? And I don't actually know, because we didn't do anything in particular to store those things in a way that was marked, but I suppose the HHA probably has it, right? Because the HHA needed to know what kind of asset each individual thing was. So the HHA probably does actually have the type, so we got a little bit of a get out of jail free card there, I suspect, if we actually store that. If we didn't, then we're in a little bit more trouble, because we don't actually know which kind of asset this actually is, if that makes sense. So right here, when we're about to actually free it, we need to know, should we call the platform, and should we call deallocate texture, right? On the bitmap header, something like this. Does that make sense? So assuming that we have to do that, excuse me, we need some way of knowing, you know, what's going on there. So let's take a look at that asset header. So here's the asset memory header, and here is the asset index, total size, generation ID, right? And here's all the various stuff for it. So we know that if we did know that it was a bitmap, all we would have to do is deallocate it thusly, and we'd be done. But since we don't actually know which one it is, we have the asset index. I'm not sure how we would tell what type of asset it actually was, because I don't know that we have any more information in there other than that. We've got the HHA, but that doesn't have it in it, right? I just looked at that. It just has the offset, the tags, and then a union, you know, one for each thing. So if I come back here to the asset and we look at it, I don't think there's anything that I could use that would give me a clue. So we probably would have to store, in order to support that shutdown properly, we'd probably have to store some piece of type information. Like we'd just straight up have to augment it, so that when we have asset memory header, it actually stores a type in here that tells you what it was actually being used for, if that makes sense. Because I don't know any other way to get it. So in here, we would actually need something. Oops. In here, we would actually need something that's like asset type. And that would tell us. Which I think we had tried to avoid doing because we really just didn't need that information in any other place. But, I mean, if we need it, we need it. And so here we would say if the asset header asset type equals HHA bitmap, we have, I believe we have an actual type field for this sort of thing, right? I assume. So we actually got away with never storing the type at all, anywhere. And this would be the only thing that actually needed it. Boy, that's a bummer. I wonder if there's any way we can avoid, like it's kind of funny that we never had to do that, and now we would have to do it. Kind of a bummer, right? Yeah, that's really too bad. Because it looks like we don't ever even have to know, and through the entire thing, it was always just assumed which one it was, and it all just worked somehow magically, right? Which is really kind of cool. But I guess, I mean, not in any real concrete way, but it's just like, hey, that's kind of neat. But unfortunately, it looks like we wouldn't be able to get away with that anymore, if that makes sense. What just happened? Okay, good. So yeah, I don't really know what else to do about that here, other than say like asset type bitmap, like that, and just store it, because I don't see any real way around it, and I think that just has to be stored. So I'll come in here and say enum asset type. And I'll just say there's an asset type bitmap and asset type none at the moment. In the future, maybe we'll actually track them all, but for now we don't need to. And so then when we do sort of the obligatory linking in, which I guess is sort of the stuff that we do up here, we do insert asset header at front. I guess, well, and we probably don't even really need to do it quite at then. We probably just need to do it in that actual allocator itself when we load the actual stuff in. So when we call load bitmap, where is my load bitmap? There it is. So when we call load bitmap, I would need to set it in places like this. So when it comes through here and it says like, okay, we're going to load this asset in, when we set these things, so in here when we take that asset header and do acquire asset memory, I guess on acquire asset memory we should force it, just to make sure everyone sets it, set the asset type. So acquire asset memory, it's right here. It's going to take an asset type. And so then when it actually gets the memory, whenever that actually has to happen, when we come down here and we do result asset index, result total size, and so on, insert header at front. When we do the insert header at front, we'd then be set to go, right? Because that's the asset memory header is the thing that stores the type in it. So we would just say, okay, assuming that we got one, the asset type is whatever it is. So, oh, right. Can't quite do that. Oops. We already used that name. Let's see. Loaded bitmap does not have an overloaded member. You are correct, sir. I did not mean to suggest that it does. And this is an asset header type. So then we might as well finish these guys. So this would be an asset type sound, and this would be an asset type font. And that's it, I think, except for the typo. Thank you, compiler. So that's that. And we'll leave it at that at the interest of closing reasonably. So I think we're all set up now. We just need to do our debugging to figure out like when we're not getting stuff and whatever. And then we should be good to go. So I'll end it there and we'll see if anyone has any questions. But that's basically the infrastructure necessary to do the texture downloading. We just gotta actually set it up. Now there is one more thing we can choose to do if we want to or not, which is we can fence the downloads. That's why I put that to do in there. We can do something called fencing the downloads, which makes it so that the OpenGL will just pause if the texture hasn't been downloaded yet. We can do that. I don't know that we actually want to, but we can. If we always hit our texture download times, we'd never have to do that. It doesn't matter. But, you know. Are we missing a day in the episode guide? The guide only goes up to day 242, but today's overlay was saying day 244. I don't know. No, I think that counter was just busted. So this is actually day 243. Sorry about that. Just correct that. Yeah, what do you mean? It said day 243 the whole time. What's wrong with you guys? You're obviously mistaken. It never said 244. Don't be ridiculous. Just look over there, a seagull outside flying around, and then see? I don't know what you guys are talking about. You're just totally confused. Gary Johansson. Is it possible to tell OpenGL which graphics card to use if you have more than one in a given machine? No, it is not. So the answer to that question is a little complicated. The short answer is no. The long answer is actually it depends on whether they are by the same manufacturer or not. And if they are by the same manufacturer, then you may be able to. If they aren't, then no. So, for example, if you have like an ATI card and an NVIDIA card in one machine, only one of the drivers will get loaded, will be mapped to you as the driver you're talking to when you ask for OpenGL. And there's no way to say, give me the OpenGL context that corresponds to that guy's card. So whoever is set up as like the primary display driver is the person who you'll actually be talking to. If you have two graphics cards in the machine and they're both by the same vendor, then it's the same driver anyway. In that case, OpenGL will by default just do whatever it's going to do. Meaning if the user has set it up as SLI, it'll SLI. If the user has set it up as like just separate and don't use the other one, then that's what it will do. But if it is, for example, NVIDIA card and it's a Quadro card, there's a graphics API that allows you to iterate over which cards are in the machine and say which one you're talking to for any particular context. If it's not a Quadro, you can't. And so you just don't have there's nothing you can do. Forget it. If it's an ATI card, I think there is a similar one that works on all their cards. So I think on ATI, you can actually say, I'm trying to talk to this card, and I want to use each card separately. That's all I know. I don't know about Intel. Since they're integrated graphics, I don't know if there's such a thing technically as having more than one, but it occurs to me that you could dual socket a Skylake, in which case you do have two GPUs, and I have no idea what happens in that circumstance. It's never even really crossed my mind. But in theory, you could, and I don't know what happens. So, Cuber Caleb, is it really a good idea to keep the DC around forever? What if the user changes their monitor config while Handmade Hero is running? Well, that's the least of our worries, because if the DC has to get rebuilt, the OpenGL context is no longer valid. So it's really the OpenGL context that you'd be worried about. But if they change their monitor config, in theory, it's not going to affect the OpenGL context. In theory. It should still work, actually. So really, we just have to reposition our window or something. Pragmascript, wouldn't the allocate and deallocate texture fit better in the OpenGL layer instead of the platform? Yeah, I think so. Because we don't... I think that's a reasonable idea, because I feel like we don't call any platform-specific stuff in there. Right? I mean, that looks totally fine for moving, so I feel like we could share them with any platform. Like if Linux or whatever wants to use this, I think that's fine. So I think that's a totally reasonable thing. So let's go ahead and do that. That should be fine. What is Microsoft's rationale for not allowing exclusive full screen mode for universal Windows platform games? Seems like that would just shoot themselves in the foot. I mean, what is Microsoft's rationale for anything? I have no idea. They're a large organization with a lot of people in it, some of whom are probably reasonable engineers who want to make a good decision, some of whom are probably just too inexperienced to make a good decision, some of whom are like actively malicious and just want to win at all costs and will intentionally make bad decisions, who knows. And that whole mixture plus deadlines plus whatever comes out to give you stuff like universal Windows platform. And then we have to live with it. And that's life. And it's not a great life. But why those things happen? Who knows? I don't even know if they do or don't. I mean, I'm never going to ship a universal Windows platform game unless it literally is the only way left to ship on Windows. So I don't care. But, you know, I don't know. Easy Sigh. Is there a way to preload vertices, normals, and colors to the card in the same way as textures, e.g. before a GL draw elements is called, or is that usually never an issue? No, actually, it's exactly the same. It's exactly analogous. And the reason that we are not doing anything like that here is because all of our information that has to do with vertices is actually dynamic. Like everything moves around on a frame. But if we found that we really needed to care about something like that, like let's say, for example, for some reason, like the background elements that tend to be in the same place, like our trees, let's say that those were really expensive, like lots of vertices, and we wanted to try to minimize that bus traffic. You can actually create a buffer for vertices the same way that you do like a texture, and transfer that asynchronously as well, if you want to. It's exactly analogous. So in general, you can kind of think about this as just the general way that you would do stuff that is expensive to transfer. Our vertices are mostly dynamic per frame, and there's not that many of them. So it's really not something that we have to care about. Most of our data lives in textures. And so, you know. Could you invite Jeff to supervise and micromanage you while coding sometime? He'd be a bad one to invite for that because he's actually a very hands-off manager. He doesn't supervise and micromanage people, which is one of the reasons I like working for him. So you'd probably want to ask somebody else to do that because he probably wouldn't be interested. Huberkill, for 3D models, isn't it typical to upload the mesh to the GPU once and write a shader that takes a transform matrix for drawing each model? Yes. And that's why I'm saying, so, in our circumstance, with sprites, it's just a card on the screen. It's 4 vertices. And if we found that specifying 4 vertices per one was too onerous, we actually don't even have to do that because there's a thing called a tessellation shader and a geometry shader and various other things that can actually blow out vertices to get you things by specifying only a single vertex and then programmatically generate the 4 vertices that would create the card. So in actuality, we just don't have to worry about vertex traffic. We can specify all the positional information we need every frame very easily, and the size of a transform that you normally send down for even a static mesh is bigger than the amount of data we send down for our sprite cards right now. So we're just not even in that same realm. But in a circumstance where you have tens of thousands of vertices, hundreds of thousands of vertices in models, then the same thing you have to do for textures here that you have to do for your vertices. It's exactly the same. We just don't have any data in vertices. All of our vertex data is dynamic. We're moving. The whole point of specifying the vertices every frame is to move things around. And so we wouldn't get any savings by taking a transform because a transform, is just as big as the actual vertex data, or very equivalent in size, essentially. And like I said, if we did want to compress down that data instead of sending the 4 vertices, we could actually just send the center and a scale and have a geometry shader blow that out for us. FSSJS. It was just for entertainment reasons. I wasn't implying anything else. Jeff saying, I really don't like the name of that variable. So the funny part about that is Jeff would hate the name of all these variables because you can actually understand what they mean. Jeff only likes A, B, C, D, E, for variables. He and Sean don't like to name variables like actual names very much. They like them to be short and concise. And hey, there's something to that, right? Less typing. I was just on RSI break. I can certainly appreciate that there's perhaps very good reason to do that. That has nothing to do with the code even. So. Cuberclub, how the heck do you even read code with 1-letter variables? Well, I mean, you can sort of do this exercise for yourself if you want. So here's STB TrueType, right? Which I showed how to use on the stream a while back. I was like, if you want to read fonts. So you can look at Sean's code here, and you can kind of see what it looks like, right? He's, they still put a fair number of variable names in there eventually. It's not all. I mean, I'm exaggerating when I say that, right? So you can kind of see that it's not so much that way, right? It's just a lot more concise than mine tend to be. Like, you're not going to have width spelled out. You're just going to have like W or something. But assuming you know what your shorthands are, and you do use longer ones in places where it's important, it's not that, you can still read this, right? And this is probably a little more verbose than I think Sean's code normally is, maybe because it's in the SDB library. I don't know, maybe not. And I think this is more verbose maybe than Jeff code would be, which might have it be even more truncated. But you can see that even when I'm saying like they're more truncated, it's not, they still have, if it's something that needs an explanation, they still kind of put it in there. It's just you'll see a lot more of like if something could be abbreviated, it was. And there's a lot more like, for things that are clearly just iterators, it's just IJK and whatever, right? They don't name them what they were. They just assume you can tell from the context, which is usually true, right? It's not that hard to usually sort of suss out, what's going on. So yeah. So is that about all there is to that? I feel like we've gotten through all of the questions. All right, I'm going to wrap it up. I'm going to wrap it on up. Hello? There we go. Or I'm going to try to anyway. Thank you for the stream. We were not doing a good job asking relevant questions, honestly. There were some relevant questions. I mean, at the end of the day, you saw what I did. It's just really babysitting the driver. I mean, all the complexity for programming graphics card on Windows is in the driver. There's nothing, even if you use Vulkan, it's still just babysitting the driver, and the driver actually does all the actual complexity of like mapping, figuring out like how to talk to the graphics card and synchronization and all that stuff is actually really still mostly all in there. So, graphics programming is largely about if you've already worked out, like we did on Handmade Hero, how we wanted everything done, transferring it to programming graphics card is really just about figuring out how to babysit the drivers properly to, feed them stuff in the way that they want them fed. But that's it. So there isn't a lot to it. Anyway, I think we'll wrap it up for now. Thank you everyone for joining me for another episode of Handmade Hero. It has been a pleasure coding with you as always. I hope that you will join me tomorrow for going through and stepping through our texture download stuff so we can get it all working, and then check that off of our list of things to do. As always, if you would like to follow along at home with the source code, you can always pre-order the game Handmade Hero on handmadehero.org, and it comes with the source code, which you can download at any time. Similarly, if you would like to use the editor that we're now using, it's called 4Coder. You can get it by typing 4Coder and return in here. I'll try to put a link on the webpage so that we know that it'll just be up here eventually. That's the editor we're using. If you would like to do it, you can support Alan Webster, who's the developer, on Patreon, and you can have your own copy of it. That is the same as the one that I am working with on stream. That's about it. We also have a Patreon if you want to support the video series. We have a forum site if you want to ask questions, and we have a tweet bot if you want to know the schedule. Please go to handmadehero.org and check those out if those are things that interest you. If not, and you just want to hang out here on the stream We will be back here tomorrow, 5 p.m. Pacific Standard Time, to do the rest of that texture programming. Hope to see you here. Until then, please have fun programming, and I will see you guys on the internet. Take it easy, everyone.